So folks, are you ready to learn how to graph tangent and cotangent? Hopefully. We've just been spending the last couple days learning how to graph all the variations of sine and cosine with period change and phase shift and amplitude and all that good stuff. So now we're ready to take that knowledge and apply it to the tangent and cotangent curves. Okay, so what you need to understand is that sine and cosine are just the basic trig functions, and that all the other trig functions, the other four that we have, can be expressed in terms of them. And for cosecant and secant, those are the reciprocal of sine and cosine. And then tangent can be defined as sine divided by cosine, and then cotangent, being the reciprocal of tangent, naturally leads it to be cosine divided by sine. So because all four of these functions can be expressed as fractions, we have to worry about our denominator being 0. And as we've seen, sine and cosine repeatedly equal 0. So each time we get a 0 in the denominator, that function is considered undefined. Well, when you go to graph any of these four trig functions, when you get these undefined values, we're going to represent those by asymptotes. And I hope you guys remember what asymptotes were, because we've dealt with them quite a lot in the past. Okay, so let's just jump right in to look at what the graph of tangent x would look like. So we're going to graph y equals tangent x, and the typical domain for this is going to be from negative 2 pi to positive 2 pi. Unless otherwise stated, that's what you're going to graph. So remember that tangent is equal to sine divided by cosine. So when we go to graph tangent, anytime the cosine curve is equal to 0, then we're going to have undefined values, right? So what we're going to do initially, not that you're going to have to do this every time, and some of you probably won't even need to do this to begin with, is just kind of plot where the cosine curve would be on this axis. Okay, I'm not even going to draw in the cosine curve because all I'm interested in is where the curve crosses the x-axis, because that's where the values are going to be 0, right? So at each of these locations, I'm going to have a vertical asymptote. So go ahead and put those in. Remember that asymptotes should be dashed. Okay? Now, because I have to go all the way out to negative 2 pi, I need to repeat this pattern. So it looks like every other tick mark, there's going to be an asymptote. So that means there's an asymptote here at negative pi over 2, and then another one at negative 3 pi over 2. Once we have our asymptotes, then what you have to understand is there should be a midpoint in between the two asymptotes. And typically when you've graphed this the way you've labeled your axes, you'll have this point already labeled in radians. So I'm going to take my blue curve here, and this will be a point, this will be a point, point, point. Okay, so we get these midpoints that are going to be the zeros. And from there, what you have to understand, I'm not going to go through the whole getting these values, but you should just understand what the look of a tangent curve looks like. So it looks like when you start here at this midpoint between the asymptotes that's on the x-axis, you're going to curve up towards your asymptote on the right. And there's an arrow because it does continue on indefinitely. And then to the left, it's going to go down. And this is really hard to draw on a computer, so you can imagine what this really should look like. It'll be a lot easier when you're doing it yourself. Okay, and then we just repeat that. This gets repeated a lot. Oops, crossed over my asymptote. Shouldn't have done that. Okay, this is taking a while, isn't it? Okay, that one wasn't quite as good. Hopefully you guys are getting the idea though. Now, these ones over here on the ends, there is no second asymptote. You can imagine there would be an asymptote over here. And from this point, I should be going down, right? I don't have to continue the part that's going up to the right since that's beyond the 2 pi. And then over here, if you repeated this pattern from this point, I'm going to be going up towards, oops, the asymptote. So there is the look of your tangent curve. So, rule of thumb, what you're going to do is figure out what your denominator is for tangent. It's cosine, right? And then look at the places where cosine is going to be 0, which becomes your asymptotes. And then the midpoints between your two asymptotes become those 0 points for tangent, and you're going to always graph up to the right and down to the left for tangent. So keep that in mind. Now, if I do any kind of variation, so say this was the tangent of, say, 2x, then I'm going to be graphing cosine 2x and seeing where those asymptotes lie. Or maybe there's a horizontal shift. Maybe it's the tangent of x plus pi over 4. So then I would be shifting cosine curve pi over 4 units to the left. And then I would be getting my asymptotes. Okay, we'll take a look at that later. I'm going to get rid of this and move on to cotangent. We'll see how cotangent is different. So cotangent is cosine divided by sine. So we're going to be looking at where is cosine 0. So if we were to just briefly plot these in, maybe you already have these values memorized. I don't know. That would be awesome if they were. Otherwise, you can always just go ahead and graph your sine curve. So it looks like at 0, pi, and at 2 pi, I'm going to have asymptotes. And then I'm going to repeat that over on this side at negative pi and negative 2 pi. Notice that this asymptote is technically supposed to be on the x-axis, but if I drew it there, you wouldn't see it. So you need to make sure that I can see this asymptote when you're graphing your problems. Okay, so just like we did before with tangent, we're going to find the midpoints between the asymptotes, and those are going to be our zeros. We'll put our points there. Okay, and then, just like we did with tangent as well, we're going to be filling in our curve the same way, only it's backwards. This time, we're going to go up to the left. Ooh, that one was beautiful. Wow. And then we're going to go down to the right. What is going on? How did I get such a good curve? That's not going to happen again. Okay, so, yep, see, messed up. And then this one, we just keep repeating it. So the difference between tangent and cotangent, aside from their asymptotes being in different spots, is the direction that the curve goes towards the asymptotes. So cotangent goes up to the left, while tangent goes up to the right. And so there you go. There is your cotangent curve. Not so bad, right? Okay, now what we need to talk about here is period. So if you look at the period of your cotangent and by extension tangent curve, because they're very similar to each other, these values get repeated. So if we look from here to here is when it starts repeating. Here to here, it's the same curve. So the period for cotangent is pi instead of 2 pi. And you can think about the same thing happened with tangent. It was just your asymptotes were pi over 2 and 3 pi over 2, so the distance was still pi. So because of that, if you're asked to calculate out the period of cotangent or the period of tangent, and it's something different, like you have a b other than 1, then you're going to use the formula of pi divided by the absolute value of b instead of 2 pi divided by the absolute value of b. That's if they're asking you for the period of tangent or cotangent. But that is not the period of sine or cosine that we would use to graph, right? The period of sine is still 2 pi, and we used that curve to figure out our asymptotes. So you got to be really careful in answering the question when they ask you, is it the period of tangent or cotangent, or the period of sine or cosine that you're looking for? Okay, so one last example. So now we have phase shift. We have phase shift in the horizontal direction, pi over 4 units to the left, and in the vertical direction, we're going 1 unit down. Okay, so first of all, what I'm going to do here, tangent is sine over cosine. So if I graph just the basic cosine curve, and I'm just putting the points, I'm not actually graphing the curve, right? So I get that. Do I have the right thickness? No. There we go. And then I need to shift pi over 4 units to the left, because I have a plus there, these values right here, each of these, when I break up pi over 2 in half, this is pi over 4, right? So this point is going to move right here. I don't really care about that point so much because it's not a 0. But this point also is going to move right there. Okay, because that was also a 0. So that's actually where my asymptotes are going to be. So if I were to plug in these values, this is at pi over 4 and at 5 pi over 4. I'm now going to have my asymptotes right there. And then I do have to repeat this pattern over on this side. So I want to see how many tick marks are in between each asymptote. There's 1, 2, 3. So on the 4th tick mark, I put an asymptote. So starting at this asymptote, if I count over 1, 2, 3, 4 tick marks, there's my next asymptote. And then 1, 2, 3, 4, there's my last and final asymptote. Now there should be another asymptote out here, but this is beyond the 2 pi, so I'm not going to worry about that. Okay, so now the next thing, I'll take my blue marker here, is now I have to figure out where my zeros are. Now zeros are going to be in between midpoint of the asymptote. So technically it would be right here at the x-axis where it's 0. But I have this shift down 1 unit. So this point right here that normally would be at the 0 is going to be down here at -1. And so this point right here, which is the midpoint between the asymptotes, is down here at -1. And this one, and then this one. Okay, so once I have that, now I can go ahead and start drawing in my curves. The tangent, remember, goes up. Whoa! Back it up there. That was terrible. We'll try that one again. Okay, so go a little slower. There we go. And then going down. Okay, and this one. Bad. You guys will be doing much better than me. Okay, now we got to deal with these things that are on the end. This one is going to go down here, but there is going to be a little bit that's going up until I get to the 2 pi. And then this one is going to be like from here kind of up, just a tiny little bit. Okay, and there you have it. There's your tangent of x plus pi over 4 minus 1. And I just realized that I forgot to write the y equals. That was silly. Okay, so this should be y equals tangent. There we go. My bad. Okay, so there you go. Hopefully these won't be too bad. You'll get a lot of practice doing this and then it'll feel comfortable. You just have to be aware of your shifting and your period change for sine and cosine, whatever your denominator is, in order to get your new asymptotes. All right, see you later.